All right, here we go. Getting started. Notes. We got this piece of paper. We're going to be talking about, as you can see on here, right triangle trig. And we see at the top, solving for the side in a right triangle. Now, if you're given two sides, this is nice and familiar. Let's go ahead and write on here the Pythagorean theorem. We've got two sides. Nice, we can handle this. And our Pythagorean theorem is a squared plus b squared equals c squared. And of course we know that the hypotenuse is opposite the right angle, so this 50 has to be our c. Then we can do some math here, we can do some calculating. We also yesterday remembered some Pythagorean, or maybe not remembered, but we wrote down some Pythagorean triples, some nice perfect whole numbers, boom, 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 that just make a nice right triangle. The easiest one, all the numbers are less than 10, what is it? 3, 4, 5. We love 3, 4, 5. We see a triangle and it might be 6, 8, 10. It might be multiplied by 3, a nice 9, 12, 15. Do we remember any other Pythagorean triples?
7, 24, 25.
Okay. 7, 24, 25. I like that one, particularly on this problem. Do we remember any other ones? There's one with 5.
12 and 13.
Nice job, 5, 12, and 13. That's one I also really like. And then there's like maybe one more. Honestly, I don't even really have the other one memorized because these three are the three I really care about. What do we got? You got it there, Dory? No big deal. If we don't have it, we don't need it, right? These are memory and they're not essential. 8, 15, 17. I like that. These are not essential. These are not required, but if you remember them, they can sometimes solve the question for you. I don't recognize 48, I don't recognize 50, but I do see a little bit of a pattern. I do see that 48 is double 24, and 50 is double 25. So I'm noticing this right here. This is looking very Pythagorean triple of it right there. That means that my other side would have to be 14, the double of 7. Because I've got basically a twice as big triangle of 7, 24, 25. And if you didn't know that, you could still solve the whole question. We didn't do one of these on the homework, so I'll just do it real quick. We could have, a squared plus 48 squared equals 50 squared. Thank goodness we got our calculator here, because yikes, that's a real mess. 48 squared is 2,304. I mean, that's awful. 50 squared is 2,500. We're going to need to subtract that to the other side. Minus 2,304. Okay, that's 196. And just like we thought, we know 196 is a perfect square root. A is equal to 14. Just like we thought. Everything fantastic. We're good on that question? All right, so this is the new today. Hopefully we're still reviewing. Method number 2. You are given one side and an acute angle. Okay. Now, honestly, I don't love that it says acute angle there, because if you have a right triangle, you're going to have an acute angle. But we need one side and an angle. If we have this, we can use a trig function. What are the 3 trig functions? They're already written on your paper.
Sine, cosine, and tangent.
Perfect. We have sine, cosine, and tangent. I suppose we have this box down here. Why don't we use this? The sine, cosine, and the tangent. Now, you might remember, don't do that. You might remember SOHCAHTOA. Always to me sounds like a Native American Pocahontas type thing. I don't know what that's all about. But SOHCAHTOA, that's what I always think of. What is the point of SOHCAHTOA? Why is it a nice, useful mnemonic? So I'll help you out with this. SOHCAHTOA,
Oh.
SCT, and where are those letters coming up? Sine, cosine, tangent. So then the only thing we need to figure out is why is it OA? Everybody's on to it. It is nice of you. I'm proud of all you guys. After summer, you might have been thinking last year, I'm never going to remember this SOHCAHTOA stuff after the summer, but seems like about half the class did, so nice job. These are fractions, and importantly, the first letter is the top, and the second letter is the bottom. You know what? I think that's going to be weird because I have the paper in there. So this is more like, oh God, what is it doing? Stop. This is more like O over H. That's not even H, that's IH. This is more like an A over H. At this point I've been writing on top of stuff over and stuff, and it's a little hard to see, but SOHCAHTOA. This is how we're setting up fractions. And yesterday we talked about opposites, adjacents, and hypotenuses, and that's all going to come in. So, for this question, I want us to start by labeling the opposite, the adjacent, and the hypotenuse. The most important thing, for me, the most important thing, because it's where we're going to start, is you have to decide, or not decide, you have to identify where is the angle that we know, right? You see this 20 here? That's the angle that we know. And so you want to think about it like that is where you're standing. I really like to draw a little stick figure in there because that really helps me kind of like identify where I am. This is where I'm at. I'm not standing at the top. I'm not standing over here on the left. I'm standing right there. So let's label these as opposite, adjacent, hypotenuse. Anybody got these?
Oh, 30.
30 is the hypotenuse, I heard him say. He's absolutely right. 30 is the hypotenuse. I'll just go with the HYP because I don't want to be making too much of a mess. So hypotenuse, check, we got it. What about opposite? What about adjacent? Is what? Yes, the X is the opposite because here I am, here you are, and opposite side of the triangle is the X. So you're right, this is going to be the opposite side of the triangle. I'll go with a OPP again just to keep it nice and brief. And that means the missing side, this bottom side, what is that one going to be called? Okay, nice. Maybe we're going a little too slow. ADJ, we got it. Now for every question, you're going to be trying to decide, do we want to use SO or CA or TOA, and the way we decide is we look at what kind of stuff we're working here. There's an X on the opposite side, there's a 30 on the hypotenuse side, and which side have we not used at all? There's an X over here on the opposite, there's a 30 over here on the hypotenuse, but the adjacent is not needed. It's not really in the question at all. So if we don't need the adjacent, are we going to choose cosine with a big adjacent there? Not really, right? We're not going to choose the cosine. Are we going to choose tangent with an A on the bottom? No. We're going to choose sine because it works with opposite and hypotenuse. And for this question, opposite and hypotenuse. That's what we got. Sweet, so let's make a little equation here. We have the sine, what we chose. We know we need O and H. As far as that goes, are we comfortable with that? Mm-hmm. And before I move on, just to make sure I kind of double check everything, do we know why it was sine that we chose?
Yes.
Okay, if that's the case, then we're doing pretty well. Now, first of all, don't call this sin. That's just kind of like math cringe. All right, sine. This is sine of opposite over hypotenuse, but we're missing some stuff here, okay? We want to have a theta after the sign and an equal sign between the sign and the fraction. So here is to me where a lot of you might be like, I totally understand this, and then be like, wait a second, what is my calculator doing? Like, what is my calculator doing? After we press sign in our calculator, okay, go ahead and press sign in your calculator.
I don't see that.
So sign is very near to the middle. It's a black button. It's a little bit on the left, and it literally says SIN right there in the middle. So after we press sign, it's going to give us a parentheses. And the way that sines and cosines and tangents work is they want to take a angle, not a fraction. They want to be given an angle. They want to be given degrees. So that's why I've put a theta here, because the degree portion, the angle, is what follows the sign. Then, after you give it an angle, it's going to spit out the fraction. So, let's see how that works. If we press sign, and make sure that you're in degree mode, if we press sign of 30, and then press enter, it's going to tell us 0.5. We gave it 30 degrees, and it spit out a 0.5. Last thing I want to do as far as the calculator here, how do we turn that 0.5 into a fraction on the calculator? Math, enter, or frac. When you press math, which is on the left side of the calculator, the very first thing says frac, which is like put it into a fraction, enter, and that will automatically chop it in there. So the trig takes an angle and it gives a fraction. Zoom tight. Okay, so let's actually do that for this question. Let's set up a little formula here. We have the sine of 20 equals O over H. Now the O value is an X, and the H value is a 30. All right, we want to try to find this out. And what we're going to need to do is solve for X. How are we going to get this X by itself?
Times 30.
Times 30 on both sides. That'll cross it out. And then we'll have our final answer there. Or not final answer, but thing to type in the calculator. X equals 30 sine 20. The 20 is a degree. It's the angle. It's the thing that the sine is going to calculate and compute. So on my calculator, I'm going to type 30 sine 20. Make sure I'm in nice degree mode. What decimal did we get when we typed that in?
10.26.
I like that. It should be 10.26. So, how are we doing with that? Anybody not getting that on their calculator? Are we in degree mode? Did you press the mode button?
Yes.
Did you just type 30 sine 20? Now, what happens if we try to make that into a fraction? Math, enter.
Big numbers.
The fraction we get is 35,000. Is that what you guys are working with?
Yes.
35,317 divided by 3,442. That is not how our answer is going to look on these pieces of paper. The most likely case scenario is that after we do this, we're going to get a decimal, and we're just going to stick with that decimal. Because if we think about this triangle, does it make a lot of sense if I label my triangle saying we have a hypotenuse of 30, nice, we have an angle of 20, nice, and we have another side of 3,000, actually it's 35,317 divided by 340. That is, no, right? That's not how the real world works. You don't have a fraction as your length of a triangle. What we need to do is just keep it as a decimal. I can't press undo that many times, so we're gonna go with 10.26. Now, a worksheet that I give you is gonna say 1 decimal place, 2 decimal place, 3 decimal place, maybe tenths, hundredths, thousandths. I don't know. So you'll know how to round one way or the other. There we go. Okay, let's get in this and then we'll just power through the rest of the notes. The definition of a right triangle sine is opposite over hypotenuse. And the cosine is the adjacent over hypotenuse. And the tangent is, you guys tell me.
Opposite over adjacent.
Nice shot. Opposite over adjacent. Okay. We good? I think we've gone so slow on this front side. I think you guys can also throw this in more or less to yourself. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. If you're good on that, we're gonna flip it. What is that? Okay. We don't have a lot on here. We're doing okay. We're gonna be, let's see, we got lunch in 10 minutes, and when the lunch bell rings, we're done. So let's get through some of these. Zoom in a bit. When the variable is in the numerator. Let's do 2 of these. You wanna do A, B, or C first? Just okay, I heard A and then we'll do B. So A, I've got angle 50, number 100, and this X here. First thing I wanna do is draw a stick figure at the angle that we are standing. And maybe after the notes, you're too good to do this, but I'm telling you, even as a teacher, I think this is like a really nice way to do it. Now that I see where I'm standing, let's label the X. Is that opposite, adjacent, hypotenuse?
Adjacent.
That is the adjacent. Now let's label the 100. Is that opposite, adjacent, hypotenuse?
Hypotenuse.
Hypotenuse. And sometimes it's good to also just think for a second, what is the one that we didn't need here? The opposite, we didn't need. So now look at SOHCAHTOA. SOHCAHTOA. We don't need opposite. That means sine, no good. We don't need opposite. TOA, no good. We don't need opposite. And that leaves us with only one option, cosine. And let's make sure we set it up correctly. It goes cosine, this thing needs to be the angle, equals fraction. The angle going after the cosine, 50. The adjacent, x, and the hypotenuse, 100. And what happened last time, if we just think about it? We multiplied both sides by 30, and that 30 showed up in the front. What's gonna happen this time? Multiply both sides by 100, and where's that 100 gonna show up? In the front. We're gonna have 100 cosine 50. So let's go to the calculator. 100 cosine 50. I'm getting a decimal, probably. I got 64.2787. Is that what we're doing?
Yeah.
Okay, nice, we have it. Now let's check if we see any instructions about decimals, how many decimals we need. Use trig functions to determine the missing side. When the new, okay, so nothing says anything about decimals. How many decimals do you guys want to do? 2 decimals, 3 decimals?
2.
2. So if we're gonna do 2 decimals, that is 64.228. Because it says 278, and that extra 8 that we don't need is gonna boost us up. I think you guys understand rounding. I think you guys got it. Now, maybe we wanna put a little x equals here to be extra sure, and here's a little bonus for you as well. And that side should also make a little bit of real life sense, right? I mean, this is a triangle in real life. Does 64.28 fit in with the rest of the numbers? Yeah, probably. If I got that my side was 1.7 and then the hypotenuse is 100, that's just not looking right. So if you want to be, again, a really nice little smart, sharp little math student, just double check that number. All right, I'm going to do this last question fast. Here we go. 52. I'm going to put my little stick figure there because that's where we're standing. I'm going to orient myself. I'm going to notice that over here, this is going to be opposite me. And this 10, that is next to me. And I'm noticing that this one down here, opposite the right angle, that's going to be my hypotenuse, which I don't need. So adjacent is what I do need. I'm working with opposite and adjacent. I need O and A. I need OA. I need TOA. So I'm doing tangent. 52 equals across x OA 10, and what's gonna happen? Where's that 10 gonna go? To the front. 10 tangent 52 and calculator. 10 tangent 52. Give me a number. 12. 12.799.
12.8.
12.8. Maybe x equals if we want to be rock stars. Okay, we're feeling pretty good?
Yeah.
All right, we got about 8 minutes till we leave for lunch. When the variable is in the denominator. Now, here's where we're at. I've been going, you might be a little snoozy. You might be daydreaming about lunch. You might be thinking this is a piece of cake. This is boring. This is gonna be probably twice as hard, maybe 3 times as hard. Now the first, that was so easy. I mean, what we just did was literally so easy. 10 tangent 52, 10 tangent 52, you're done, right? That was so easy. So if you're thinking, I'm bored, boo, here you go. Lock in a little bit, give me a good 5 minutes, and we'll be done for the day. Draw my stick figure. Whoa. Here we go. Draw my stick figure by the angle where I'm standing. I'm just choosing wherever that little angle is. That's where my guy is. 10 is that opposite adjacent hypotenuse. Opposite. X. Hypotenuse. Which one do I not need? Adjacent. I don't need it. So am I going SOHCAHTOA? I'm going OH. I want to choose, oh, it's hard to read. So I'm going to choose the sine of 25 is equal to fraction. Now remember, this is supposed to be O over H. So which number is top? I say which number. Which thing is top, 10 or X? 10. And that means that X is going to be in the denominator. Now this was predictable because it literally says when the variable is in the denominator. And guess what? Our variable did end up in the denominator. So now we need to solve this for X. And honestly, my experience in the past with Algebra 2 with trig students is when we get back from summer, probably half the class doesn't really know where to go from here, okay? A lot of people, it would be so nice if we could just move the 10, right? If we could just get rid of that 10, then the X would be by itself, but that's not the process we want to go. Our number one issue right now is that X is in the denominator. And if that X stays in the denominator, this question is going to be cursed forever. We want to get rid of that. So, how do we get that X out of the denominator? Multiply. Right, so same thing we did before. How did we get this 100 out of the denominator? We did times 100 times 100. So how are we going to get this X out of the bottom? Times X times X. Whoa, Mr. Cole, you're dude. Times X times X. And now, is the X out of the denominator? Yes. Now, from this point on, I think everybody knows how to solve it. We want X by itself. How do we get the X by itself? How do we get rid of this? We want to divide that. So, if we divide that to the other side, x is equal to, what's on the top? 10. Because we're going to be dividing both sides. And then what's on the bottom? Sine 25. Don't be the same guy.
My fault, I didn't mean to.
I'm just kidding, it's all good. There's probably, plenty of teachers in the city that say sin, and shame on them. Alright, so let's do this. 10 divided by sine 25. Quick little question here. Did you do alpha y equals to make a nice fraction that looks like this? Or did you do sin, with just a little fraction? Well, I'm pressing alpha, which is green, y equals, which is up there, to make a nice fraction so that I can press 10 on the top, I can explore the bottom, I can press sine 25, and then I can press enter. Alright, I got x is equal to 23.66. Thoughts on that answer? Does that look good?
Yeah.
We're going for 2 decimals, we said, and 23.662, that 2 is not big enough to bump me up. Now, in the sense of this triangle, does 23.66 make sense up here?
Yes.
I think it looks pretty good. It should be the hypotenuse. It is bigger than 10. It's not, imagine we get an answer and it says 12,000. That's not looking good. So it doesn't take a lot of brain power just to double check. All right, we're going to do a question here. We're going to power through it, and then we're going to be done. Please take these notes. Please take these notes. We're day 6 or 5 of class. Let's do it. I'm going to draw a stick figure. I'm going to label that opposite doesn't look like we need it. Hypotenuse is there, and adjacent is there. I need adjacent and hypotenuse, so I need cosine. Cosine of 48 is equal to fraction, adjacent 12, hypotenuse x. And then you go, dang it, x in the denominator, ugh. Now think about what happened just for a second. We started off with the x in the bottom. What ended up in the bottom? So do you see, check this out. Do you see that the x, which started off in the bottom, ended up over here, and the sign, which started off over here, ended up in the bottom? So if we want to be like shortcutters, what happens with the x? It switches place with the trig function. The x kind of switches with the trig function. Again, I would recommend you make sure you press alpha y equals enter to make a fraction. 12 divided by cosine 48, enter. I got a number, is it bigger or smaller than 20? Nice job. It is x equals 17.93. I cannot round up because 3 is not big enough to round yet. Does that make sense in the sense of this triangle? Yeah, I think it looks good. How do we feel about the calculator stuff? Cool, we're done. Let's